Did you know that raw sewage from over 4.2 billion people is dumped into the world's waterways every day? In Australia, when we flush the toilet, most of our household wastewater is treated before it's released. So what does this mean in terms of the values we place on these environments? It begs the question, would you continue to go to your favourite swimming spot if you knew it's where your poo pours into the river, whether it's treated or untreated? Some people do this for necessity and others simply for recreation, which led to my research question of what happens in nature when our treated poo is added to a river. One of the biggest issues with our household wastewater ending up in our rivers is the amount of nutrients that's in it. We find that most of the time, good bacteria that live in the water recycle the nutrients that flush in. However, nutrients at high levels can lead to some microbes growing uncontrollably. Remember, it was only last year that these outbreaks killed over 1 million fish in the Murray-Darling Basin. This makes bacteria a great thing for us to study because they're everywhere and they're extremely sensitive to rapid changes in their environment. We hypothesized that if we know what the bacteria are doing when we add nutrients, we could use our mathematical models to predict with more certainty what might happen in our rivers if we add more in the future and when it might be safe for you to go swimming. To do this, we use cutting-edge science and genomic tools in the field and laboratory to identify the bacterial communities we found in the river based on their DNA, and to learn about how they grow and function when we added different amounts of treated poo from different wastewater treatment plants. You can think of a bacterial community as not unlike our own, just on a tiny scale. They hang out with their friends who have similar likes to them or who are good at the same things, but they also mix with bacteria that have different likes and skills. This diversity is embraced and makes their communities more resilient. Our research showed that these communities changed a lot over time as we added more and more nutrients. The bacteria that liked more nutrients grew and those that didn't disappeared. This was the first time ever that we've had this kind of insight. This is an important finding because even our treated poo can push bacterial communities to be less resilient. And like us, if a group of essential workers for that community are exposed to further unexpected stress or changes in their environment, it could result in that function being lost and the system could collapse. Sound familiar? It's in understanding how our environment works that we find its true value. My research is important because the relationship we have with our rivers comes down to its ability to provide some tangible values to each of us. That is it good for swimming, fishing, boating, or whatever it might be? We need to better understand how our environment works to drive the values we want from it. And with this research, we are taking steps towards that outcome.